Hello and welcome to step 11, where we're going to talk all things Pythagorean theorem. You may have seen this before, maybe like in 8th grade when you did a geometry unit, but we're going to reiterate it because all of unit 3 is everything to do with right triangles. So in order to use Pythagorean theorem, we have to have a right triangle. That's super duper important. This does not work if we have any other type of triangle. So we know a triangle is a right triangle if it has a right angle. So you might have a 90-degree angle labeled, or remember our little box down here will always show that right angle. Okay. So the other thing we also have to point out is in a right triangle, we always have a side that's called the hypotenuse. Okay, the hypotenuse is always the longest side, which usually you can tell. If you can't tell which one it is, it's always the one opposite the right angle. Okay, and it's always labeled as C. The other two sides we're just going to call legs for now, and they're just shorter. We can call them A and B. So our Pythagorean theorem is one of the shorter legs squared plus the other shorter leg squared, and that will equal the hypotenuse squared. Okay, so the basis of this, I'm going to draw you a little picture so you can see it. If we had a right triangle, let's say this is side A. If we constructed a square, I know this probably isn't going to be a nice square, and we found the area of this square, it would be A times A, or A squared. If we did the same thing down here, and we called this side B, the area of this square, because all the sides are the same, B times B, B squared. And then you're probably seeing where I'm going with this. If this is our C, because that's our hypotenuse, and we draw another square, right? All the sides would be C, and C times C, C squared. So the area of these two squares added together would equal the area of this third square. This is actually true if you do this with any regular shapes, but specifically it's easier to see with squares. All right, so let's do an example here. Okay, so we always have A squared plus B squared equals C squared. Okay, so the two smaller sides are going to be A and B. Doesn't matter which one we deem those. But the longest side, always opposite that right angle, is our hypotenuse, and that's going to be C. So we can already see that X is going to be our C. Okay, and then the other two really don't matter. We can put 6 in for A, 15 in for B, and then we're going to go ahead and solve. So 6 squared, 6 times 6 is 36. 15 squared, 15 times 15 is 225. Okay, we're going to go ahead and add those together, and we get 261. So we do have, technically we do have X by itself, but we still have to get rid of this squared, okay? So the opposite of squaring something is taking the square root. Okay, looks like a little radical sign like this. Okay, so let me show you on the calculator how to get that. So you can see, hopefully, it's in blue on this little X squared here. So if you hit the blue second key and then this X squared button, you'll get your radical. So you're going to type in 261. Okay, 261 is not a perfect square, as you can see. So we're just going to round it to one decimal place. So this would be 16.2. So X equals, we can either leave it as the square root of 261 or 16.2. All right, let's do one more just like that. Okay, so again, A squared plus b squared equals c squared. Okay. The longest side, our hypotenuse, is always going to be our c, so that's going to be 11 here, so we'll put that in for c. And again, the other two sides, doesn't matter which one we put in for a or b, as long as those get plugged in. Okay, so we can't simplify x squared, so that just comes down. 9 squared is 81, and 11 squared, 11 times 11 is 121. Okay, so you're probably thinking, Mrs. Duncan, this is different, right? Last time we had x by itself, this time we don't. So we're going to solve just like we would any other equation. We have to get x by itself, so we'll subtract 81 on both sides. So 121 minus 81 is 40. And then again, we have to get rid of that square root or square, so we square root. Okay, we type this in our calculator. Again, second x squared. 40 is not a perfect square, so we can either say the square root of 40 or rounded to 6.3. All right, we got a couple other examples in here. So we also have what's called Pythagorean triples. So these are nicer like shortcuts if you can see the triple. So the most common ones that we might see is like a 3, 4, 5. So if you see me like make up an example, I might make it a 3, 4, 5 multiple. So these are all going to be nice right triangles where they're going to actually give you whole numbers. So anytime you see three numbers where one's a multiple of 3, one's a multiple of 4, and one's a multiple of 5. So we're just going to look at one of these and maybe see it. So again, not necessarily required to memorize because you can always use Pythagorean theorem to figure it out. But this one is asking us to locate the triple. Okay, so what I would look at is take the numbers that you know, so 15 and 12, and think, what is the greatest common factor between 15 and 12? Hopefully you're thinking, well, we could divide both by 3. So 15 divided by 3 would be 5. 12 divided by 3 would be 4. So we had one number that's a multiple of 5, one that's a multiple of 4. So that fits in this first column, okay, in the 3, 4, 5 list. So we've already gotten a 4 and we've already gotten a 5. So we're missing the multiple of 3. And we multiply these two numbers by 3. So 3 times 3 would be 9, which we can also see in the list right here, 9, 12, 15. Again, just a little shortcut. It's helpful for any math teacher when we have to think of an example. We always know that those are multiples. Oops, forgot to erase that. All right, let's do one more example. So we have Damon is locked out of his house. Uh-oh. The only open window is on the second floor, which is 12 feet above the ground. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from the house to avoid some bushes, what length of ladder does Damon need? Okay, so it looks like our unknown is going to be the length of the ladder. Okay, we have a nice right triangle because we're going to assume that the house is perfectly vertical to the horizontal ground. We're going to use our Pythagorean theorem because we're missing a side of a right triangle. Okay, our unknown is our hypotenuse, right? It's opposite the right angle. Then I'm going to plug in our other two sides. So 5 squared, 5 times 5 is 25. 12 squared, 12 times 12 is 144. Okay, this time those are on the same side, so we'll combine them. 25 plus 144, 169, I believe. And then we will square root that. So second x squared, 169. Oh, and we get a nice 13. So 13 feet is the height or the length of the ladder. Okay, and that is part 1 for step 12. Sorry, step 11. Thanks for watching.